Welcome fellow learners. In this video, we are going to explore custom agents provided by Langchain. We will see what are the applications where we can use these custom agents and how these custom agents can be implemented in Python using Langchain. So before diving into custom agents, let's first explore what are the agents. So the core idea behind agents is to use a language model to choose a sequence of actions. So if I can give you an example, so if you want to create a chat with data kind of application where we want to chat with a SQL database, so what are the different sequence of actions that an agent would try to use? So it will first convert your natural language question into SQL query, then use that SQL query to fetch the data from the database, and then finally use the fetched data and the user's question to provide the summarized answer to the user. So these agents are also having benefits over using chain. So like the chain are of basically having a fixed sequence of actions within them. So we basically provide a fixed sequence of actions in a prompt, and chains will only use that sequence of action. While agents can choose it at runtime which particular action it needs to execute at that particular step. Agents can also use or utilize less number of prompt tokens if there are multiple tables in the database and it only requires few tables to answer the user's question. These agents can also recover from the errors while it is not feasible for the chains. So if you think about it, how these agents are basically able to achieve these benefits. So all these agents are already integrated with different tools. So if I take an example, a predefined agent, create SQL agent provided by Langchain, that agent is already integrated with four different tools in it. So those tools are like it can list down the tables, it can fetch the schema of the table, it can ask LLM to generate the query, SQL query from the user's question. It can also check the query, generated SQL query, if that query is correct or not. So in that way, these agents can utilize those tools and basically uh, give us the better results than the chains. So if you want to learn more about agents, I have already created a video about the agents. I will share its link in the description and you can go through it. So now we know what are these agents and where we can utilize them. Similarly, we can create our own custom agents also. So let's take an example where I wanted to use a LLM which can also give us the answer to the recent events. So first I tried to get the answer using GPT 3.5 turbo model. So I asked it like what are the two teams are going to be in the finals of Champions League 2024. So if you see in the answer, GPT 3.5 provided like I'm sorry, but I cannot provide real time information. So then I created a custom agent and asked it the same question. And you can see it was correctly able to find out like Dortmund and Real Madrid are going to be in the finals of Champions League 2024. In this way, we can utilize custom agent to achieve the results that we wanted. So somehow, if we can integrate Google search with the language model, we can achieve the result which we want. So we can use Google search as a tool and then integrate it with the agent. But if we are using a predefined agent, it would be more difficult to explain the list of the tools that are already integrated with the agent and then append the Google search tool in it. So the problem would be like agent need to think it more and find out which particular tool to use for which particular task, and the accuracy would be lower, which we wanted to achieve. So for that purpose, we can create our own custom agent where we are going to utilize only single tool in it, which will be the Google search tool. Now we know the specific task that we are going to basically solve. Like we want our language model to also answer about the recent events. So we will be using only a single tool and then integrating it with the agent, which will be your custom agent basically. So I hope you got little understanding about what are these agents, custom agents, and where we can use these custom agents. Now we are going to implement this custom agent using Langchain. So let's get started. So let's first see what are the different steps that we are going to follow in this notebook. In the first step, we are going to import the language model. For the language model part, we are going to utilize GPT 3.5 Turbo model. In the second step, we are going to import the tool which we are going to use in the custom agent. This tool would be basically Google search tool. In the third step, we are going to bind this tool to language model, and then we are going to create a prompt template. This prompt template will be utilized by our custom agent. And in the final step, we are going to create a custom agent, and we will be utilizing these language model tool and the prompt template that we have created in the previous step. So let's dive into the code. We will first import our language model. Here you can see the model is GPT 3.5 Turbo model. Now we can run a few examples and see if it is able to answer. So like as our problem statement is, we want a language model where we can get answer for the recent events also. So if you can see here, I have asked a recent event. So it was basically a cricket match between RCB and CSK was basically held on 18th May 2024. So let's see if it is able to answer this question. So if you see in the answer, it says like it is not able to provide the real-time information as it is an AI assistant. So I tried to ask it a different question, which is also a recent event. So like which are the two teams that are going to be in the finals of Champions League 2024. So let's see if it is able to answer this question. So you can see it is also not able to provide the answer to this. It is saying that it is not able to predict which two teams will be in the finals. But it is already declared that the finals will be between Dortmund and basically Real Madrid. So we can see that individually GPT 3.5 Turbo model is not able to answer about the recent events because it is being trained on the past data. So if we can see the data for the GPT 3.5 Turbo model, it was basically last updated on November 2023. So it can't have the data after that. That's why it is not able to answer the recent event questions. So for that part, we are going to create a custom agent. So as we have already seen the steps that we are going to follow in this notebook. So in the second step, we are going to import a tool. So we are going to use Google search tool. For that part, you first need to import two libraries. The first one is Google API Python client, and second one is Langchain Google community. So the first one is basically for the part where we are going to use Google API key for the Google search, and the second one is Langchain has created a separate library for Google community. So different like Google search run would be there and Google search API wrapper would be there. We can import these modules directly from that. We need not to use Langchain over here. We can directly import Langchain Google community and get these modules from there directly. So another thing that you would be required here, you need to create your API. So let's first run these cells, and if you see in this Google search API wrapper, there are few links provided for us. So like it's in the docstring of this for this one Google search API wrapper, in the docstring of this Google search API wrapper, it has provided that you can create your API from this URL, and then you can create your this Google CSE ID from here. You can create a custom search engine and you would be able to get your Google CSE ID from there. So in this way you can get your Google API key. It has limit for certain number of basically requests per minute. for which it is not basically asking for any price to us. It is free for certain number of requests per minute. So we are going to use Google search API key to utilize Google search tool and basically use it with our agent. So let's run this cell. Now we are having our Google search tool. So let's run a simple question to it and see how does it basically provide us the result. So if we run the first cell, I have asked it a simple question like who won the match between RCB and CSK on 18th May 2024. You can see it fetched the result from the search engine. You can see it is from the different basically pages, and we are not able to see the exact answer like who won the match. We need to read this little basically cumbersome or tidy string, and if we use or if we bind it with the language model, we will be better able to see the answer. I have also tried it to see the result from particular website. You can write it like site colon and the particular site's name, and you can fetch the results from that particular site directly. So this is the result from that site. If you want to see the result from one particular site, you can get it from there also. So now we can see we can use this Google search tool and we can fetch the result from it. So the next thing is we are going to bind this tool to the language model. The purpose of binding this tool to language model is that in every call to the language model, this tool is always available with it. And also like as we are going to use OpenAI tool calling, which is basically best way to get the result from the agent in an efficient way. It is basically fine-tuned to basically tool calling. So it needs to be basically formatted in a way as OpenAI tool format requires. So for that part, we need to bind this tool, Google Search tool, to the language model. So we are only using this single tool, Google Search. You can add different tools over here like Wikipedia and all. But we are, as per our problem statement, we are going to use only this one particular tool over here. So let's run this cell. Now we are having our language model, which is already binded with the tool Google Search. Now we can use this tool with the agent. Now we are having language model. We are having our tool also, and also we have binded that tool to the language model. So in the next step, we are going to create a prompt template. As we are going to utilize OpenAI tool calling, which is already fine-tuned for the purpose of tool calling, we need not to provide much instruction to the language model. So we are only going to utilize two things. One is input and second one is agent scratchpad. So the input is basically user's question, and the agent scratchpad is basically kind of notepad for the agent, which it will utilize for a single call, where it will keep the actions that it has taken in the previous step and the different tools it has called in the previous step. So these two things we are going to utilize over here. And let's run this cell. Now we are having a prompt template with us. So let's finally create a custom agent. So two other utilities that we are going to use to create a custom agent is, the one is we are going to format the basically the input to the OpenAI, how this input will be given to the OpenAI, and the second one is how the output from the OpenAI or the language model will be basically passed as part of the agent action or the agent next step. So we are going to utilize these two, format to OpenAI tool messages and OpenAI tool agent output parser. So if you see, this is basically a runnable sequence where in the first step, it is basically taking user's input question as input. Agent scratchpad will be basically empty in the first step, but it will be filled in the later step. And this will be the first input to the prompt. As you have already seen, the prompt will take two input and the agent scratchpad. So it will take these two and fill it in the prompt. In the next step, it will utilize this prompt and then pass it to the LLM with tool, which is already having tool, Google search tool, which will be passed to it in every basically call. Now, once it fetch the result from the LLM with tool, it will basically pass the output result to the OpenAI tool agent output parser and fetch the result. Similarly, this step will be iterated again and again until agent is provided with the agent finish action, such that it need not to run any tool or any step anymore. Then it will provide us the final result. So in this way, this agent is being created. This is the runnable sequence, which will be basically run step by step. The first step would be this. It will format to OpenAI tool message. Second, it will pass to the prompt. Then that prompt will be passed to the LLM with tool. And then output from the LLM with tool will be passed to the OpenAI tool agent output parser. So let's run this step. Now we are having our runnable sequence. So let's create a agent executor. So before that, if you see, I have created this, I have imported this get OpenAI callback. This is being used to see how many prompt tokens are being utilized by the agent and what are the costs associated for each call. So now we are going to create agent executor. Agent executor is basically a runtime for the agent. So this is going to call agent, see the result and see the output, then again run the step and then again call the different tools. It will basically monitor all the steps and it will be kind of a runtime for the agent. So we are going to pass agent to it, this runnable sequence, the tools, which is basically Google search tool. We are only having one tool. Verbose is true for basically seeing the intermediate step results. And stream runnable false is basically used to find out how many prompt tokens are being used in one particular call. So let's run this cell. Now we can run our examples that we have seen. We were not able to get result when we are calling GPT 3.5 turbo model directly. So let's run first question and see how this agent, custom agent is providing us the answer. So if you see, it has invoked Google search first and it fetched all these things, all these results from the search engine. And then in the output, you can see it has given us the result like Royal Challengers Bangalore won the match against Chennai Super King on 18th May 2024. You can clearly see it is able to fetch the result and which our GPT 3.5 turbo model was not able to answer individually. You can also see how many tokens it utilized. It utilized 702 prompt tokens and generated tokens are basically 58. It called two times. The first time it basically find out which particular tool it needs to call, which is Google search. And at second time, it basically summarize result for us, this final result. Let's run the second question also, like which two teams are going to be in the finals of Champions League 2024 and see how it is giving us the result. So you can see here it has given us the correct result that the two teams which will be in the finals of the Champions League 2024 are Dortmund and the Real Madrid. So you can see in this question also it is able to provide us the result and the tokens utilized by this are 644 for the prompt token and 51 are for the generated tokens, completion tokens. It has also called language model two times. Great. I hope you got the understanding of how you can create a custom agent using Langchain. So I think we have come up a long way. Like we have first used GPT 3.5 turbo model as a LLM. Then we used Google search tool, which is available in the Langchain. And then we basically bind that tool to the language model such that it can be passed at each call to the language model. Then we basically created a prompt template which can be utilized with the custom agent. And then finally we created our custom agent and tested with the questions that we have already asked to the GPT 3.5 turbo model. And we have seen how GPT 3.5 turbo model individually was not able to answer about the recent events, while when we have created this custom agent, we were able to get the answer for our questions which were related to the recent events. So great. I think uh, we have completed this video tutorial on custom agent. In the next video, I will be basically explaining how we can add memory to this custom agent. So great. Thanks for making till the end of this video. Goodbye until the next time.